Let's go on page 45 when we're done. These are actual notes, yes. Okay, so the first thing we're going to look at is limits with end behavior. And if we are talking end behavior, we are talking way out at the infinities. So we should have a horizontal or slant asymptote. Now, not for everything in the world, but when we're talking about rationals, and that's what we're dealing with right now, okay? So if we're talking about rationals and we're talking about their end behavior, horizontal or slant asymptote, okay? And way out at the ends, which is at the infinities. So left end behavior is when x approaches negative infinity. Right end behavior is when x approaches infinity, because we're talking at the ends. We don't care about what's going on in the middle right now, right? Also, along with notation, when you get your quizzes back, I may have changed your notation or kind of fixed it or written little notes. That doesn't necessarily mean I took any points off. If you had all the pieces, but they were just kind of a little weird, then I was trying to help you along the way, because clearly you were trying and you knew what you were talking about. And I know that when I write it as well, it doesn't always look like it does when it's typed, because I don't have the best handwriting, and sometimes it's hard to get this part right here real tiny right under LIM. But you can tell the difference between somebody that's attempting to write it correctly and somebody that doesn't understand how to write it correctly. You with me on that? So like it can't, I've seen limit and then next to it x approaches infinity, then next to it f of x, or leaving it off or just doing other strange things. So be careful with that. The other thing that I saw from a few people was having a line here, almost like it's a fraction. So no lines there, and just this is the x approaches whatever is right underneath the LIM. Okay? Make sense to you? So just kind of work on that, because notation is huge for AP. Like you could lose points just because your notation was wrong, even if you understood the rest of the concept. So we don't want that to happen. So yes, sir. No, if we're going, this is the x's. When x approaches negative infinity, I'm going to the left. When x is going to infinity, I'm going to the right. We're talking x's, not up and down. So the verbal description, basically what you say for that is the input values, or as x decreases without bound, so as x approaches negative infinity, then the output values whatever, right? And as the input values, x increases without bound, approaches infinity. Okay? So two different ways to talk about it. Approaching infinity is increasing without bound. Approaching negative infinity is decreasing without bound. And we're going left and right on the x-axis talking about that. Okay? The answer is what's happening to y. So graphically, we have this first graph here, f of x. So we have the limit as x approaches negative infinity. So as x gets smaller and smaller and smaller, what is y approaching? 1. Okay? As x gets bigger and bigger and bigger, what is y approaching? 1. Okay? Because we have a horizontal asymptote at y equals 1. Okay? So as x decreases without bound, the y values are getting closer and closer and closer to 1. As the x values increase without bound, my y values are getting closer and closer and closer to 1. One of them's approaching 1 from above, and one's approaching 1 from below, but it doesn't matter which way it's approaching it. It's just approaching it. Okay? So here, and the vertical asymptote had nothing to do with what we were talking about, because we're talking in behavior at the asymptotes. Here, I have another vertical asymptote. Has nothing to do with my infinities. Okay? Nothing to do with the x is going to infinity. This time I have a slant asymptote. So as x approaches negative infinity, what is y approaching? Negative infinity. And as x approaches infinity, what is y approaching? Infinity. Because on this one, we have a slant asymptote at y equals, okay, I think we can, yes. If you're talking in behavior. Yes, yes, yes. Yes. So if you're talking in behavior and the answers are infinities, is that what you're asking? Then that means it's a slant asymptote, absolutely. Because you're going to have either a slant or a horizontal. So I think we can use y equals mx plus b here. So looking at the slant asymptote, what's the slope? Yeah, so the slope is 1, so it's x, and then my y-intercept is 2, so x minus 2. Okay. Everybody okay with all that so far? All right, so that's looking at a graph, right? So let's talk about what if we don't have a graph, what if we were looking at equations? So just like we had said, if we have a horizontal asymptote, then the y value is the limit when you're talking in behavior. So if I look at f of x here, f of x, is it top heavy, bottom heavy, or tied in degree? Good, tied in degree, so my horizontal asymptote is at y equals 2 over 5. Since that is my horizontal asymptote, thank you. Let me make sure they're all here before you walk off. Is everybody here? Everybody's here, right? Okay, everybody's here. We're good. All right, so since that is my horizontal asymptote, that is my answer to my limit. Oh, I can write it correctly. 2/5, positive and negative, because that's what we're approaching. Yep. Every time. For the end behavior. If that was as x approaches 3, that would be a totally different issue. We wouldn't be looking at the horizontal asymptote, we'd be looking at something else, okay? But if we are looking at end behavior, you're looking at the horizontal asymptote or the vertical asymptote, okay? All right, so g of x, top heavy, bottom heavy, or tied in degree? Bottom heavy, so y equals what? 0, which means my answers are 0. Now, a couple other things about notation here. If this is g of x, this should be g of x. That's what some of y'all got some points off on your quiz. G of x, but you were writing everything in f of x. Well, you can't talk to me about f of x if this is g of x, okay? And again, this works, and we're using this because we're going to the infinities, not to something else, okay? Everybody good with that? Okay, good. Then it says the degree of the numerator is greater than the degree of the denominator. Then you're going to approach positive or negative infinity. Okay, because we're going to have possibly a slant asymptote, but not necessarily. With a graph that you're going to look at or try to have to graph, you're not going to get anything crazier than a slant asymptote. But in a question like this, we could look at something more than a slant asymptote because we don't have to understand a ton about it. But either way, the end behavior will mirror the end behavior of the leading terms, the ratio of the leading terms. So if I look at k of x, I can see that it's top heavy, so that means no horizontal asymptote, right? Top heavy by 1, so we know it gives us a slant asymptote. So we could divide and find the slant asymptote, but nobody's asking me for the actual slant asymptote right now, so I don't need to do that, right? Yes? If it's greater by 1, yes. Yes. If it's greater by 1, it'll definitely be a slant asymptote. But I can't, but I don't need to do all of that. So instead, I just need to see what the end behavior is going to look like. So I can just take these first two terms, and I get x cubed over 2x squared. And when I reduce that, that gives me 1/2 x, which is not necessarily my slant asymptote, but it is parallel to that line, at least. So that gives me the slope. I don't even care exactly what the slope is. All I care is that it's a slant asymptote and it has a positive slope, so it has to look like this, right? Something like that. That's what my slant asymptote is going to look like. And then that will help me with the end behavior. So as x approaches negative infinity, what is y going to be approaching? Negative infinity. And as x approaches infinity, positive infinity. All right, so then r of x, here I'm going to take, it's top heavy, so I'm going to take the ratio of these two terms. So negative 3x to the 5th over x cubed, right? When I reduce that, that gives me negative 3x squared, okay? That's not the exact asymptote, but it gives me the end behavior that I need. That has an even exponent, so that means that the ends are the same. That's negative, so it's down, down, right? That's my end behavior. So as I approach negative infinity, it's negative infinity, and negative infinity. Okay? We good with that? That is all end behavior. And I know it's end behavior because it's either going to tell me, talk about the end behavior, or the limits are approaching infinity, which are the ends, right? Not technically the end because you never get there, but you know what we mean. Okay, so vertical asymptotes and limits. So when we look at vertical asymptotes, we look at it from both sides of the vertical asymptote. It's different than looking at end behavior. This is more your middle behavior, right? And we're only looking to the immediate left and right. So let's look at the graphs in our notation first here. So here, I'm not approaching infinity. I'm approaching 2 from the left and the right. And that's another notation thing that you need to pay attention to. Some of you left off these little plus and minus signs. They mean something. So this says the limit as x approaches 2 from the left. So as I'm approaching 2 from the left, what is y approaching? Infinity, right? As x is approaching 2 from the left, y is approaching infinity. As x is approaching 2 from the right, what is y approaching? Negative infinity. Okay? So this specifically says as x approaches 2, but let's say that this was as x approaches c from the left, just to generalize it so it's c and not just, so some number. That's not necessarily 2. So if I have a vertical asymptote at x equals c, then the limit is going to equal plus or minus infinity. Because when we're approaching a number and we're talking about rational functions, we're talking about either vertical asymptotes or wholes, okay? And so if I know it's a vertical asymptote, my answers have to be infinities, and I just got to figure out which one it is, all right? So verbally, again, as x approaches 2 from the left, these were the words I was saying on the graph. As x approaches 2 from the left, f of x approaches infinity. And as x approaches 2 from the right, f of x approaches negative infinity. Okay. What questions you got about that? Okay, so let's look at the equations then. So now I don't have a graph to look at, I just have this. So, and I know I want my limit as x approaches 1, so I have to figure out what's going on at 1. So the first thing I look at is there anything I can cancel out? The answer to that is no. So this is where I have x minus 1, so that means I have a vertical asymptote at x equals 1, right? And so I know my answer is either positive or negative infinity. I just got to figure out which one. And I figure out by which one with the equations by creating a sign chart. So on my sign chart, I put my zeros and my asymptotes. So I have 3 things that go on there. I have a 0 at negative 4, an asymptote at 1, and a 0 at 3. Do I have to do the entire sign chart? No, I do not. I have, all I'm concerned with is where the asymptote is, right? But I do, and you don't have to put the zeros on there, but I do think it's a good idea because then it allows you to use whole numbers, which I think you're more comfortable with, without using the wrong ones. Like I can't use a negative 5 or a positive 4. I don't want to go on either side of that. Okay, so between negative 4 and 1, I can use 0. I need to pay attention to this guy. Even though there's not an x on it, that sign definitely affects the sign of the outcome. So I have, that's a negative. When I substitute in 0, the next two things in the numerator are negative and positive. The denominator gets squared, so it's positive always, which means this is positive overall. Then between 1 and 3, I can use 2, so I still have that negative to start with. Then a negative, positive, positive in the denominator, that's positive overall. So what that tells me is, on either side of that asymptote, it's going to look like this, and I have togetherness. So as I approach negative 1 from the left, it's infinity, and as I approach from the right, it's infinity. Okay. What questions you got? We good? Yes, because some people are using them wrong. Okay, so you might want to check that on your quizzes too. Like, I think with the letters, I don't know that some of you know what they really mean. So, all right, so limits and wholes. So here, notation looks the same, right? If you look back up here, the limit is x approaches 2 from the left and 2 from the right. It's the same thing as right here. Of course, we have f of x and g of x, but it's the same thing otherwise. But when I look at my graph, different things are happening. So as x approaches 2 from the left, what is y approaching? 2. As x approaches 2 from the right, what is y approaching? 2. Okay? And it just happens to be the same number, which kind of bothers me. I wish that I had changed the number. But either way, as x is approaching 2 from the left, I approach 2. 2 from the right, I'm approaching 2. As x approaches 2 from the left, y is approaching 2. As x approaches 2 from the right, y is approaching 2. That's at 1. Nobody's asking me about 1. Okay. So when you have a whole at x equals c, then the limit equals the y value. Now, it doesn't equal c. I know it looks like it does here, but it's the y value. The y value and the x value just happen to be the same number. It's the y value of the whole. It is a bad example. You're right. I've regretted it all day. All right. So then, again, verbally, what I just said is x approaches 2 from the left. It's 2. As x approaches 2 from the right, it's 2. Yes, I have a vertical asymptote. I can have 20 vertical asymptotes on there. If it ain't at 2, I don't care what's happening right there. We're just looking at what we're asked for. Okay? It's not the y asymptote, it's the y value of the whole, because it's not really an asymptote, but yes. And so then tell me, what is the value of the function when x equals 2? If I substitute, so if I had the equation and I substituted in 2, what would I get? Undefined. Okay, it's undefined. So just like if I substituted in 1, the function is undefined when x equals 1. And the function is undefined when x equals 2, but for 2 different reasons. One's an asymptote and one's a whole. Okay? That makes sense? All right, good deal. Okie dokie. Let's look at the equations here. So, for equations, we can find the limit value at a whole by plugging in the x value. So when I look at k of x, the first thing I do is there anything that I can cancel out? And yes, there is. So this means that I have a whole at x equals 3. And that's good because I'm looking at, so I also have a vertical asymptote at 1, but it's asking me about 3. It's not asking me about 1, so I don't care about the asymptote, right? And so in order for me to find this, I just need the y value of the whole, so I need k of 3 after I have reduced it. So that's going to give me 3 plus 5 over 3 minus 1. That's 8 over 2, which is 4. What questions do you have? So this is the 3 different types of limits that deal with rationals, kind of all in one place as a little reference sheet. You might want to keep it handy for the little activity that we're going to do, and then you can put it in your ISN. But I'm going to ask you another question. I'm going to ask you a question in just a second that you don't necessarily have to write down. Angela, you have a question? Or Angie, I'm sorry. Where am I going? Even more? Hang on, I'll come back to your question. I substituted it. I'll go back down there in a second. You got it? Okay. You got it, Angie? Yeah, okay. All right, so let me ask you a question. You don't have to write this down, but if I had a function and it looked like this, let's say 1 over x minus 3 plus 1. Okay? You don't have to write that anywhere. How is this different than the rational functions we've been looking at? It has a plus 1, right? All the rational functions we've been looking at is just one fraction, right? So if we're going to use all the things we know about rational functions, they have to be all in one fraction. So if I needed to figure stuff out about this, because right now it looks like it's bottom heavy, right? If I would need to combine these. Do I get to just add the 1 to the numerator? Okay, you do not add it to both. But when I add fractions, what do I have to have? The same denominator. So I'd have 1 over x minus 3. What will my common denominator be? X minus 3. So that 1's going to become x minus 3 over x minus 3. Right? Common denominator. So then when I combine that, in the numerator, x minus 3 plus 1 gives me x minus 2. My denominator is x minus 3. So it's not bottom heavy, it is tied in degree, right? I have a 0 at 2, which I couldn't see in this form, and I couldn't see that it was tied in degree. So, and the little activity that you're going to have, oh my goodness, I don't even know how I just did that. And the little activity you're going to have, a couple of these are going to pop up, but they're real simple like this. They don't get crazy, okay? So you should be able to get a common denominator. Yes? Yep, exactly. That's the easiest way to do it. Okay, we're good? Anything else? All right, good deal.